Hey class, welcome to week 3 of Algebra 2. This week we're going to be looking at quadratic pattern. So we have already been dealing with the quadratic pattern right here, where we have the standard form and we have factored the standard form. So today we're going to look at what happens when the x squared is a bigger exponent. For example, x to the fourth, and then the x squared, and then our constant. So we really handle these two problems in a very similar way. We're going to use the x factor. So let's quickly review factoring this one. We'll take a times c on top, put our b value on the bottom, and then our two numbers we're going to use here are going to be -10 and 1. Now I'm taking these examples from your notes page in the packet in Google Classroom. So we do things a little bit differently than the other Algebra 2 teachers. That's why I'm doing these two problems with you in my own video. So remember, at this point, what we do is we make two ratios where we put the a value in the numerator. Okay, and then we go ahead and simplify or reduce the fraction if we can. Always keep the sign in the denominator. So now we have a factor of 1x minus 5. And we have another factor here of 2x plus 1. Okay, so that's our typical way of factoring. So now let's take a look at this one. This one is x to the fourth, and this one is x squared. We're going to go ahead and factor this one the same way. A times c on the top, b value on the bottom. We're going to come up with our two numbers as usual. Notice nothing different, but you do need to recognize when it is to the fourth power, to the second power, that you can factor this using the x factor. Okay, so now we're going to go ahead and put our a value on top, reduce it. Now, here's where it's a little bit different, so please pay close attention. So notice on this one, we did 1x minus 5. This time, instead of 1x, we're going to do 1x squared. So this factor is going to be 1x squared minus 5. And this one's going to be 2x squared plus 1. So where we get the x from here is x to the first is half of 2. Same thing here. Half of 2 is 1, and that's how we get our x minus 5, our 2x plus 1. For here we're going to take half of 4, which is 2. So x squared minus 5, 2x squared plus 1. Now notice, if we multiply these together, we should end up back where we started in standard form. Right now, we're in factored form. So if we multiply these together, x squared minus 5, 2x squared plus 1. So 2 times 1 is 2. X squared times x squared, we add the exponents, x to the fourth. 2 times -5, and then the x squared gets tacked on. 1 times x squared, 1 times -5. And then we go ahead and write down our answer with our highest exponent first. Combine our like terms. So 1 minus 10 is -9x squared, and our constant. Notice standard form. Now, if you ever do this, be sure, this is important, be sure to look at these factors to see if you can continue factoring. For example, let's say that you end up factoring it and you get something like this. Okay, this is what I like to call a twist ending. In other words, you took a problem, something like this, and you factored it, and you get something like this. And then you're like, whoa, that's a difference of 2 squares right there. So then you need to break this down, x plus 2, x minus 2. If you don't know that shortcut, you need to use the x factor in order to factor this to this. And then this one's not factorable, so that one would stay the same. Now this is very important. Watch out for the twist ending. Again, let me say this again. You have a problem. You factor it. You get your 2 factors. Now notice this one isn't a difference of 2 perfect squares. 5's not a perfect square, so we can't factor that further. And we can't factor this one further either. So we're done. But if you get a problem and you factor it, and you look at your 2 factors and you think, those are perfect squares. X times x is x squared. 2 times 2 is 4. 1 plus, 1 minus. Make sure you factor it completely. This one's not factorable, so that one just came straight down. All right, thanks for watching, guys, and I hope you're having a good week.